Hello students, we are solving the IB Math A AGL past papers and currently we are solving the IB Math A AGL May 2022 paper 2 time zone 1 past paper. Today we will be solving the question number 11 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel in this online math tutoring classes. So without any further delay, let us start solving question number 11. The maximum mark is 60. A bakery makes two types of muffins, chocolate muffins and banana muffins. The weights C grams of the chocolate muffins are normally distributed with a mean of 62 grams and standard deviation of 2.9 grams. Okay, so that means C is a normal distribution variable and the mean is 62 and the standard deviation is 2.9, so it is 2.9 square. Okay, because we have to write the variance. Fine. The subpart A says find the probability that a randomly selected chocolate muffin weighs less than 61 grams. Okay, so we have to find the probability of probability of C rather, C less than 61 grams. Okay, so using GDC, let us go to the calculator and it is menu and I can go to the probability or statistics, anything, distribution, and it will be normal CDF. Okay, so normal CDF less than 61. So I am keeping it like this, whatever value they have given, I am keeping it like that. And this will be upper bound will be 61. And the mu is 62 and the standard deviation is 2.9. Okay. So we write norm CDF and taking the lower bound as negative infinity and then 61, 62 and 2.9. You have to write this because otherwise you don't have any other step to be written to prove that you have done something in order to get the answer. Okay, this is equal to 0.3651121. 0.3651121. Okay, let me check it once more. 0.3651121. Okay, fine. So this is equal to 0.365. Up to 3 significant figures. Okay. The part B. In a random selection of 12 chocolate muffins, find the probability that exactly 5 weigh less than 61 grams. Chocolate muffins, we have already used this. Let us see, let us take M. Okay. This is the subpart B. Let M denote the number of muffins that weigh less than 61 grams. Okay. Now, there are 12 muffins. We have selected 12 muffins. So the number of trials is fixed. It is 12. And the probability of a muffin weighing less than 61 grams is also fixed. It is 0.3651121 over here. Okay? And up to three significant figures, it is 0.365. And there are only two outcomes, possible outcomes. Either a muffin will be weighing less than 61 grams or it will be weighing greater than or equal to 61 grams. So the number of trials is fixed, the probability of success is fixed, that is the muffin weighing less than 61 grams. There are two possible outcomes, and of course, the trials are independent of each other. Because if the first muffin is weighing less than 61 grams, that doesn't in any way affect the weight of the second muffin. The second muffin can also weigh less than 61 grams or can weigh more than 61 grams. Okay. Doesn't matter what is the weight of the first muffin, previous muffin, or what will be the weight of the next muffin. So the trials are independent. Therefore, it is a case of a binomial distribution. Okay. So, therefore, M is a binomial distribution variable. Number of trials is 12 and probability of success is 0.365, 1121. Okay. And we need to find P of M equal to 5. So, using GDC, the menu, probability, you may take probability or statistics. Anyway, you come to this distribution part, and now it is the binomial. It is you may take binomial PDF because it is exactly equal to 5. When you have exactly one number, then you can use binomial PDF. But if you have the condition that it should be greater than this, but should be less than that, then you have to use the binomial CDF. If you want to use the binomial CDF in this case where you are having exactly one value, then you have to give both the lower value, lower bound as 5 and the upper bound as 5. Okay? But in case you are having the exact match, then you may use the binomial PDF as well. So let me take the binomial PDF. And N, it is the number of trials, so it is 12. Probability of success, it is 0.3651121. And the x value, it is M equal to 5. So, okay. So, we will be writing this binom PDF and 12 0. Twelve 0 point, oh, 0.3, okay, 365 1121 and 5 equal to 0.2136661. 0.2136661. 2136661. So this is equal to 0.214 up to three significant figures. Okay. The weights B grams of the banana muffins are normally distributed with a mean of 68 grams and standard deviation of 3.4 grams. Okay, so this B is a normal distribution variable with mean as 68 and standard deviation as 3.4. So it is 3.4 square. Okay. And they are saying each day 60% of the muffins made are chocolate. So 40% of the muffins will be banana. On a particular day, a muffin is randomly selected from all those made at the bakery, means both the chocolate muffins and the banana muffins. The question C has two, the subpart C has two further subparts, I and II. The I says to find the probability that this randomly selected muffin weighs less than 61 grams. Okay. So it can be a banana muffin or it can be a chocolate muffin. So let me first of all get the probability of B less than 61. Okay. So it is menu probability distribution, and this will be I'm taking normal CDF and less than 61. So let it stay. The lower bound is staying as it is and upper bound is 61. The mu is equal to, the mean is 68. 68 and the standard deviation is 3.4. Fine. It is 0.0197, 0.0197555. 0.0197,555. Okay. Let me check 0.0197555. Okay. Now they are saying a muffin is selected at random, so it can be either a chocolate muffin or a banana muffin. So for that, we have to draw the tree diagram. This is the maybe the chocolate muffin. This is the banana muffin. And 60% of the muffins are made are chocolate. So this will be 0.6, the probability, and this is 0.4. And this one is less than 61 grams. In weight, this is greater than or equal to 61 grams. We do not need this part. So I am interested only in this one. This part, it is 0.3651121. And this also is having two branches less than 61 and greater than or equal to 61. So this is less than 61 is 0.0197555. Okay. So this is the G diagram. You may find the probability of this part and this part. It will be 1 minus 0.3651121 for this, and it will be 1 minus 0.0197555 for this one. But we do not require these values, so I'm not writing, I'm not wasting time in getting those values. Okay. Therefore, probability of the weight less than 61 grams should be equal to, it can be a chocolate muffin, so it is 0.6 times 0.3651121, or means plus 0.4 times 0.019755. Okay, so we have to just use our calculator to get the value. 0.6 times 0.365 1121 plus 0.4 times 0.019755. Okay, enter. It is 0.2269, so it is up to 3 significant figures. It will be, okay, first of all, let me write this actually. 0.2269695. 0.269695, which is approximately equal to 0.227 up to 3 significant figures. Okay, so this was the answer for the subpart I. And now we come to the subpart II. Given that a randomly selected muffin weighs less than 61 grams, find the probability that it is a chocolate muffin. Given that, that means it is a conditional probability. So, probability that it will be a chocolate muffin, the condition is weight less than 61 grams. Okay. So, this is equal to probability of chocolate muffin weighing less than 61 grams over probability of muffin weighing less than 61 grams. So this is from the tree diagram, you can see this is the probability of a chocolate muffin weighing less than 61 grams. So I'll be taking that branch for the numerator. So this is 0.6 rather. Times 0.3651121 over P of W less than 61 is this number. This is, don't take this, okay, because for intermediate calculations, you don't take only three significant figures. You give the final answer up to three significant figures, okay? So this will be 0.2269695, okay? So this is equal to 0.6 times 0.365, right? 0.3651121 over this is the thing, 0.2269695 enter 0.965 up to three significant figures I'm taking 0.965 0.965 up to three significant figures. Okay. The machine that makes the chocolate muffins is adjusted so that the mean weight of the chocolate muffins remains the same, but the standard deviation changes to sigma grams. The machine that makes banana muffins is not adjusted. The probability, that means this stays as it is, and this one gets changed to, the mean stays the same. So it is 62 comma sigma square. Okay. And now they are saying the probability that the weight of a randomly selected muffin from these machines is less than 61 grams is now 0.157. So we had drawn the tree diagram. This was the chocolate muffins, this was the banana muffins, and 60% of the muffins that are made are chocolate, so it will be 0.6, and this is 0.4. And we knew that the this part was less than 61. So what was it? Less than 61, 68, and okay, and 3.4. Yeah, this was this 0.0197555. 0.0197555. 0.0197555. And this also has the less than 161 branch, but we do not know the probability of this. Okay. So, what can we do? We are writing P H less than 61 is equal to 0.157 given is equal to, let me write this as x. Okay. So, this is 0.6x. X is the probability of a chocolate muffin weighing less than 61 grams. So 0.6x plus 0.4 times 0.197, 0.0197,555. Okay. And we have to find the value of x. So it is, therefore, x is equal to which is P of C less than 61. This is equal to 0.157 minus 0.4 times 0.0197,555 over 0.6. Okay. Now let us find the value. The numerator is 0.157 minus 0.157 minus 0.4 times 0.4 times 0.0197,555 over 0.6. Okay. This is 0.2484963. This is equal to 0.2484963. Right? 2484963. Right. Fine. Now we are having the probability of a chocolate muffin weighing less than 61 grams is equal to 0.2484963. Okay. Now we have to find the value of sigma. This is the question for subpart D. Okay. So we do not know the value of sigma. That is why we have to find the value of sigma. And whenever we don't know either the mean or the standard deviation or both of them, what do? We use the standardized normal distribution variable, that is the z. So we will be using that. This is normal distribution variable with the mean as 0 and the standard deviation as 1. Okay. So we have to see less than 61 is this. So the probability will be remaining the same. Therefore, P G less than, say, small z is equal to 0.2484963. And now since the probability is known, whenever the probability is known, we go for the inverse normal. So we will be using the inverse normal function. So menu probability distribution inverse normal. Okay, the area is this one, the probability. 0.2484963. Mean is 0 and the standard deviation is 1 for the standardized normal distribution variable. So this is this. Okay. So we can write using GDC inverse norm. This one's 0.2484963 comma 0, comma 1 is equal to minus 0.679 minus 0.679 and 2293. 2293. This is the value of this small c. Okay. And what is the relation between x and z? We know that. In case you are not remembering, you can use your formula booklet. Okay. So this will be x minus mu over sigma. So in place of z, I am substituting this minus 0.6792, sorry, 922 6792293. Okay. Equal to x. What was x? It was 61. C is less than 61. C is less than the small c. Okay. So x value will be 61. What is the mu? Mu, you see, this is, you can see this is 62. The mean remains the same. So this is 62 over sigma. Now we are having a equation, an equation containing a single variable. So we can find the value of sigma. So this is sigma equal to 61 minus 62 is negative 1 over negative 0.6792293. Okay, these two minus signs will be getting cancelled, and let us find the value of sigma. So 1 in the numerator and 0.6792293. Okay. Enter 1.472257. So up to 3 significant figures, it is 1.47. Okay. Which is equal to, therefore, sigma is equal to 1.47 up to 3 significant figures. Previously, the sigma value was equal to 2.9, and now the sigma value is equal to 1.47. Okay, so this completes our question number 11. And thank you for staying with me till the end. I'm Nilanjana Sanyal. I am an online IB Math A, HL and SL level tutor. I tutor students from both within India and outside India, and I provide one-on-one and small group online tutoring sessions to my students. And currently, I am solving the IB Math A, HL past paper questions, and I am uploading these videos in my YouTube channel. You're watching these videos, and uh, in case you are liking my explanations, please to give this video a like, and please to share this video with your friends so that even they can get benefited by watching this video. And in case you have any question, please feel free to write to me in the comment section. I'll be trying my level best to answer your doubts and confusions. Okay? So, we meet again very soon, and please do not forget to subscribe to my YouTube channel. Actually, it will be motivating me to make more math videos for you. And we meet again very soon in our next session where we'll be solving the last questions as is the question number 12 of the same paper. So till then, bye.